Hi, I'm Alan Ross. We're here at the RE Plus Conference and Exposition. We're talking to thought leaders about the future of the energy economy. So join us and enjoy. My next guest is Martin Milani. Martin, thank you for joining us.
Thank you.
Sunverge Energy.
That's right.
I got it right. See, you got all these names with something after them, like that. So tell me a little bit about yourself and your role. You're the CEO and CTO, probably CMO, probably CCO.
Probably a few more C's, but it's been a while since I've acted as an executive, but I also have a technical background.
Right.
I'm a software engineer by formal training, and have been stayed pretty technical over the years. So
Right.
I have a pretty good concept around the technology, and also how do you commercialize that technology?
Right.
Typically, I think when there's a lot of innovation involved, you need to figure out how to make that innovation into commercialize the innovation.
Right.
And I think there's a part of it that's engineering, and then there's a part of it, how do you commercialize it to make sure that it actually gets adopted, mass adopted going forward.
So Sunverge, tell me how you got involved with it and why. Because you're not like 20 years into Sunverge. You're what?
About 6 years. About 6 years.
All right.
So I always thought that energy storage was the missing link for the grid 2.0 or grid of the future. Or the smart grid.
Yeah.
So I think smart grid had a lot of definitions going back to 2008, 2009 about sort of self-automating, self-securing, self-optimizing, and so on and so forth. But at the end of the day, I think one of the major areas that was missing was energy storage.
Right.
You have a real-time system. An electrical system is a real-time system. And it was very difficult to manage it in a way without the ability to actually store the energy.
Right.
So I was very interested in energy storage. I was very interested in intelligent energy storage, which meant energy storage with intelligent software around it for control and optimization. Yeah. And Sunverge was probably one of the most advanced companies at the time. Sunverge as a company was founded on that concept. It wasn't founded for energy storage as purely backup power or an off-grid solution. Sunverge was envisioned as energy storage that was going to be operated as part of the grid, and it was going to be instrumental and integrating with the rest of the grid.
And intelligent.
Right.
Okay, one of the big problems we have is at utility scale storage. That's still a problem. There's some people that we've talked with here at this conference about utility scale storage, vanadium flow batteries, and bromine zinc flow batteries and things. And that's nascent. That's a relatively newly developed. You are on the other side. You're behind the meter storage. And part of the problem, part of the solution that I see they're bringing is if you use a lot of the lithium to make those big scale, you're taking lithium away from where it works best, like my iPhone.
That's correct.
Right?
Yeah.
And behind the meter where it's close to the consumer, and that's where Sunverge works.
That's
right?
where Sunverge comes, right? I mean, from an engineering perspective, or scientifically speaking, or mathematically speaking.
Oh, I love the way you're talking dirty now. Thank you.
You want to solve this problem at its node. So you want to solve the problem at its sort of kind of lowest common denominator.
Right.
And that would be at the premise. That would be close. You want to solve this problem closest to where the load is that you're going to solve that problem. So hence, whether it's residential, whether it's commercial, whether it's industrial, you want to be able to manage and sort of kind of decompose the grid into a bunch of endpoints and optimize at each endpoint. So that's typically how mathematically you solve very complex equations. You break them into little pieces and optimize them one piece at a time.
Okay. So tell me a little bit about the marketplace, how you go to market, how you solve. What makes Sunverge unique at that node?
What makes Sunverge unique at the node is a couple of different things. Our approach and our vision has always been to holistically manage So we don't only manage energy storage. And by the way, we no longer just manage our own energy storage. We also manage other people or third-party energy storage systems. But now we're managing energy storage plus PV generation. So it's generation, storage, and load control holistically and at the same time.
Okay.
Continuously optimized against local conditions and as well as against grid conditions. So co-optimizing behind the meter and in front of the meter.
Oh, okay. So one of the problems all the way through that grid is inverter problems,
Yep.
right? Inverters,
Sure.
to me, it's now the weak point. It's
Right.
whether you do it at a major solar field and you got an inverter there, number one reason that you have failures there is because of the inverters, all the way down to at your level.
Sure.
So tell me how you manage that problem or eliminate it.
Well, I mean, by doing real-time control. So the ability to actually controlling these things real-time. So one of the differentiations between what we do, at least in our immediate market, is the fact that we are locally connected to that inverter. We are sort of kind of reading that inverter in milliseconds. We are also reading the grid in milliseconds. We are understanding what's going on the grid. We are understanding what's going on behind the meter. We are understanding what the inverter is doing. What's the health of the inverter? What's the health of the battery system? What's going on with the load? And what are the things that are affecting? What the weather conditions are? And we are sort of kind of looking all of this in high resolution and high, sort of kind of high resolution, high throughput fashion.
Are you omniscient and omnipresent? You're almost in like a godlike status of knowing all things around it.
So it's that.
You can use that in marketing, by the way.
So having, you could say that.
Okay.
So basically having, at some point when your time slices get so small, then you can actually see everything at the same time, right?
Yeah.
I mean, if there was a God and they could sort of kind of, that would be the very definition of it. So, so in a way, having that local context. So why that helps is also when you're getting to automation, when you getting to things like artificial intelligence, the more data, the faster that data is available. And one thing that's currently pretty hard to do with artificial intelligence is having context. What is going on at the site?
Yeah.
Not necessarily looking from outside in to look at a bunch of metrics and trying to figure out what's going on, but actually have a multiple types of data points to sort of kind of give you a good view, or I forget the sexy term, the situational awareness locally with respect to local conditions and local grid conditions, which are often unknown to the utility. Utilities are pretty well instrumented down to the substation, or they have good telemetry. But when you get far below substation, there is very little telemetry or data. So when you get, which is becoming more and more important today, because of DERs are affecting the grid, PV penetration is affecting the feeder, but there's very little telemetry in terms of what is it doing and how it's doing and where it's doing it.
Yeah.
So having that kind of intelligence of what's going on the grid and what the DERs are doing and what the grid could be doing to the DERs as well and how they can help each other and that is a short time span problem. You need to solve these things in a very short time span, or if you solve them 10 minutes later after they happen, it kind of doesn't matter.
You mentioned something, the effect of like my house, my car, my battery on the grid, when now you've got step everywhere. Power's going down, power's going up, and that creates a lot of transients, creates a lot of problems. DER in and of itself creates problems, but how does your system, because yes, you want to help the homeowner, the person I assume that pays, that's your ratepayer, your consumer, but if it also helps the grid, if it helps the utilities manage better, that's got to be in their best interest too.
Absolutely. So, I mean, at the end of the day, we have a rate-based system.
Right.
So the utility basically, in order to manage the grid and optimize the grid and make sure you get, electricity 7/24, 365 all the time, they have an infrastructure, and then all the ratepayers pay for that infrastructure. So the more optimized the grid, the more resilient the grid, the better it is for the consumers, the less cost they pay. If you could figure out a way to reduce line loss from 6% to 1%, the consumer actually gets the benefit. So it is all one grid, and I think unfortunately, I think if you look at the regulatory construct, there's a concept of the meter that's introduced behind the meter, front of the meter, but that's just an optical illusion. I mean, the grid terminates at a socket with whatever you plugged into it, right?
Right.
And the meter is just some passive device that things just go through. So in many ways, it's the single system, and you just need to sort of so you have two ends to that system, the utility and the consumer. So you need to optimize for the consumer, things for self-consumption, backup power, demand charge reduction, time of use, things that basically reduce the cost of electricity to the consumer and increase resiliency or reliability. Reliability is also very important to the utility because they get sort of measured for that, KD and SAIDI.
Yeah.
As well as making sure that the grid itself is optimized. So when utilities sit and do resource planning, they all start with load.
Yeah.
They count every home. They have an estimate of what every home sort of load profile is. And then they sort of look at things like line loss, and they fudge it a little bit, and they put some kind of an overhead on top of it and say, okay, I need X, I'll make sure I can do 1.05X, so therefore I have enough supply to meet my demand. So I think with the differences with DERs is now you also have generation sitting on the other side where the load is. So now you have to look at it very differently.
Yeah.
So now you have to solve it, and you have to figure out how to. So you go through the same process, but now you actually need to understand what the load profile, the generation profile, and the optimized profile of each endpoint is, and put all the endpoints together. And it's a different problem, but it's a problem that needs to be solved. And the grid is nothing but the sum of all the load and sum of all the generation and some of all the assets that are involved in putting it together. So I think there's no way to solve one and not solve the other side of that equation.
So you've got kind of a holistic approach to the grid down to that home. One of the problems that I think is being created, one of the problems that you have to deal with, because your technology from the battery perspective is lithium-ion, right? Lithium-ion. Lithium is a major problem. It is today, and it's going to get worse. It's not going to get better. How do you deal with that?
We from SunVerge's perspective, we stay technology agnostic. So if there are other types of batteries, and there are other types of batteries that are coming into the market from a residential, at the residential scale as well, it's a matter of, for us, it's just a matter of controlling them. We came from an energy storage background, but we basically are now focused on controlling energy storage, whatever kind of energy storage.
You want to control the world. You want to make sure, whether it's Tesla or Generac or SunVerge, that you've got a stake in it.
Right.
Yeah, okay.
And I think our differentiation is, or our difference is, our real-time capabilities.
Okay.
The fact that we can respond to things in milliseconds. The fact that we can sort of holistically manage each node.
Right.
But also our algorithmic perspective, or our algorithmic construct, which is a distributed algorithm. So you optimize every node, then you optimize a collection of nodes together.
Right.
So not only that our data is going back and forth between our aggregation or cloud tier and our endpoint or edge tier, but also algorithmically they're interconnected. So we get self-learning algorithms on the front, and we get self-learning algorithms in the back. These are Bayesian algorithms, so these are statistical, stochastic algorithms.
Oh, good. I love it. He's talking dirty again. I love that.
And by the way, those types of algorithms is exactly the kind of algorithms that if you trade the NASDAQ and buy yourself a trading platform, you get a buy signal or a sell signal. That's the exact kind of algorithmic framework that they use.
Okay. I want to switch gears. I want to go to something that I thought we both knew and loved, but I love, and I know you know, I'm not sure how much you love it yet. IEEE. I've been an IEEE volunteer for about 15 years now, and I'm on the steering committee for the IEEE Smart Grid, Grid Edge Conference and Exposition in San Diego next year. I'm also on the steering committee of the Smart Grid program within IEEE and dabble in smart cities. But IEEE is a unique organization that it's really run by engineers to make the world a better place. And so much of the power that comes from volunteers. It's just huge. We did a call for papers for the IEEE Smart Grid. We were overwhelmed. We have far more papers than we can publish. We had a call for panels. We were overwhelmed, and we got some great panels, heavily industry focused, which is better than academic. I'm not picking on the academics, but they're academic, you know. So we've got a lot. What is your involvement with, I know you support IEEE Smart Grid, but just how do you do that? I want to know if you love it like I do.
Well, of course. I mean, you know, going back, I mean, you know, again, I'm not going to date myself here, but you know, IEEE has been around for a long time, and I can tell you that any time that I'm going to try to go back and understand a concept, I go and look at some IEEE papers.
Yes.
All of these IEEE papers are written by volunteers.
Yeah.
And, you know, unfortunately, in the last several years, I have not been as, you know, as engaged, simply because running a company is different than being an engineer. But at heart, I'm still an engineer, so I'm still reading a lot. But in my view, I think some of the best papers I've ever read come from IEEE material. And in fact, if you want to go and even understand what the market is going to do 3 years from now, there are probably some IEEE papers from 15 years ago that have a very good description of that.
Right.
So I think that's what gets me excited about working with IEEE is you know, that whole, you know, spirit of innovation, that spirit of, and it's not just innovation with pictures, but innovation, what I call is innovation with formulas.
Yeah.
And that's what, because it's easy to describe a problem at a high level. It's very easy to describe, it's very hard to propose a solution to a lot of these problems. And I think IEEE, a lot of IEEE members, and IEEE as an organization not only defines the problem set, but there are a million different ways of solving that where you find a lot of IEEE material. And that's what, you know, engineers feed on each other. I mean, that's a, you know, as a whole, you got a bunch of engineers together, they get a lot smarter as a whole than as individuals. And I think that's what that's what excites me about working with IEEE.
Excellent. Smart Grid, I read a paper from 2001, and it was on power quality issues that we're seeing right now, and it was written as a Smart Grid paper in 2001.
That's
We're
right.
at 2022. Everything written then was prescient about what we're dealing with right now. So it's amazing to me, including the predictability of the volume of losses based on power quality issues. And they weren't even talking about the power quality from DER, because I don't think they were really thinking about it that much then, which was quite fascinating. What is your involvement with the Grid Edge?
At this point, just working closely with the guys and sort of kind of giving a lot of feedback, because we are one of the few companies that are looking at the Grid Edge, not just from perspective of an endpoint, but also from the perspective of the grid itself. And you know, I think there is a lot of innovation to come on the Grid Edge. I think the ability to have the DERs to be overlaid on top of the distribution grid, the distribution schematic, the ability to do the kinds of things with DERs that one would do with traditional grid assets, things like state estimation, power flow optimization, optimal power flow. Those are the things that I think are needed. There's a lot of theoretical literature out there right now, but there is not a ton of kind of product development going on. So I'm working with the guys, because this really needs power system engineering, but at different types of power systems engineering. You're going from solving a linear equation to solving a highly nonlinear equation with boundary values. And I think that, there are very few, the folks at IEEE that I work with and the Grid Edge team are the kind of people that really understand that. So it's been a great sort of a conversation because, again, as you mentioned, not too many people really discuss these things at a deep level.
Right.
And a lot of these things were thought of years ago. There was something I read a while ago that Einstein, had a vision of something, and then it took 130 years to have equipment that actually measured to say that, in fact, he was right, what he had envisioned.
Yeah, I know, amazing.
So there's a little bit of that in IEEE as well.
Yeah, that's true. We're going to be doing these kinds of interviews at the San Diego conference in 2023. I'm going to interview you again. What question should I ask you then that I'm not going to ask you right now?
What I've done since today.
Okay. So what progress have we made?
Progress, correct.
And because things are happening much more rapidly than they have been in the past. In terms of decarbonization and conversion, I hate to say it, but it was a government policy that kind of got this Inflation Reduction Act, basically said, okay, you've got a 10-year window. You can now start to plan better than you could when every couple of years they decided to renew something or not renew it, or give a credit or not give a credit. So you would like to think that the industry itself did it, but a government intervention did it. However, a war in the Ukraine also helped move this forward because of what's happening in Europe, because of decarbonization. It has to happen quicker. So there's a lot of outside influences that are allowing us, somebody said causing. I said, no, we've already been doing the cause. What they're now doing is allowing us some predictability. Because people don't want to invest in something that the rules are going to change in 2 years.
That's correct.
You want to be able to know that you've got a runway. And I think we're going to surpass the 10-year expectation of that runway.
I agree. And I think, look, I mean, there's a little bit of also the psyche of the population in general, right? I mean, people take the whole decarbonization effort a lot more seriously today than they did 15 years ago.
Right.
And I think 5 years from now, they're going to take it a lot more seriously than they're taking it today. So I think this is an irreversible trend. This is kind of progress towards that. And I think as you get the demographics changing and the younger generation is going to come up, I think this is just going to accelerate. And I think there's so much data point that we have today, and we always had the data point, but I think there's far more now that to point to the fact that we got to start this process, and we got to start this process today. And I think that will have a huge effect on the future, because this is not going. It's a little bit different than what you had in 2008 and 2009, where it was kind of like a government and a new administration came in. Hey, these are some cool things to do. And not necessarily the rest of the industry wasn't there. But I think there is so much. I mean, every major utility in the country has today, in the world, has decarbonization goals themselves, irrespective of what the regulators are telling them.
Right.
Every large corporation has that. Every city, every small city, large city. So all of this is going to sort of kind of accentuate this progress, which is. I think it's badly needed, but it's going to help to make sure that this thing continues to go forward.
So let's see what I ask you 7 months from now at the Grid Edge conference, and thank you for joining us, Martin.
Thank you.
Appreciate it.
Thank you.
So all of these interviews that we have conducted have been sponsored by the people behind me. The first one is the Grid Edge Conference and Exposition, which takes place in April 2023 in San Diego. The IEEE PES Grid Edge Conference and Exposition has been a long time in the making. This will be our first one, and it will be a delight. I can already tell you that we've had more papers, more panelists than we could possibly hold, and the conference itself is going to be brilliant. The second organization sponsoring us is H2Scan. H2Scan is ubiquitous in the transformer industry as the best. It's kind of like Intel, it's inside. H2Scan is a hydrogen sensing technology that is patented, that has been around for the last 20 years. It really came on strong as transformer hydrogen became a problem. DGA recognized by IEEE, And I just thank the people at H2 Scan. They are also in electrolyzers, fuel cells, battery storage, but hydrogen safety is incredibly important. They're in refining, in processing, so H2 Scan, thank you. Lastly, RE+. We are at the Renewable Energy Plus Conference and Exposition, and as we close this one out, I want to thank them for allowing us to conduct these interviews here, for allowing us to be part of their incredible conference. It's been enormous. Been 27,000 people that have attended this conference, and you can tell the energy, the excitement that's taking place within the renewables industry, so thank you, RE+. It's been a delight to do these interviews, and I hope you've enjoyed them.